Okay, so as Mark introduced a little bit, so this is my last tutorial, and this is nothing specific to glass, but it's more focusing on AR development, especially focusing on outdoor AR development. I think Mark might have shown you quite a lot of other applications using AR as well. So, and especially I will be focusing on using one of the software libraries we developed at the HitLab, and which helps you develop outdoor AR applications for mobile devices and also including Google Glass. So did Mark show you this AR for Glass website or you? So this is our website. That's not where. There we go. So this is our AR for Glass website where we post some updates of development at the lab, how we use especially glass for AR applications. If you go there, you'll see a couple of projects going on. Oh, but my internet connection. There we go. And yep, so there are a couple of projects up there. Actually, most of them are just a test of test report of using other software libraries for AR on glass and see if it works. So there, if test Euphoria, which works quite well, and also NIR Toolkit, which is basically a Java version of AR Toolkit, pretty much works well on glass as well. And Unity also works pretty much well with glass. I think Hidong shown you some demo of how to work with Unity with a couple of plugins to make AR applications. And sorry? And AR Toolkit. So if you're aware of AR Toolkit, which is quite an old library developed at the HitLab, which is a C++ library that detects square markers, the black square markers. So this is a Java version of AR Toolkit, which is also could be run on Android devices since it's Java-based. So this is nothing to do with Google Glass. So this is all about all the libraries that it's available on the internet that you can download and develop AR applications. So this page is showing we've tested them on Google Glass as well. So just to show you that they work on Google Glass. So if you want to do some AR applications, you can download those libraries and use yourself. So and some of the projects includes our own development, such as I think Mark might have shown you this using gesture interface with Google Glass using Kinect and so forth. So those information are also up there. If you want to look at video clips or so, download there. One of our earliest application we developed for Glass was this City Viewer, which was initially an Android app we developed for Christchurch, where we are based. And this is to show 3D building models in place so that Christchurch experienced a severe earthquake in 2011 that about, I think, almost half of the buildings in city center is now demolished. And like here, you can see now there are only container box shops, and this is how it looked like before the earthquake. So they had these kind of buildings in this place and so forth. So this is a view that you can see on a Google Glass and watch how it looked like before the earthquake. And this app is developed using the software library we've developed. So did Mark show you this video clip? No. So maybe I'll just briefly show you how it looks like. Of course, this is an edited version of the video clip. So this is a captured screen on the glass, and this is the live video. How it looks like, and this is all using sensors, so using gyroscope and compass so forth. And if you point at some building, you can read some text about that building and see the picture, how it looked like before. And if you go back, you can also see some panorama pictures, what happened right after the earthquake. So you can see how the city was damaged, and then see how it looks like physically and how it looked like before the earthquake with nice buildings. So that's basically what City VR is. And again, for today's tutorial, I'll show you how to use the outer air library to build this kind of outer air applications, such as City VR. So maybe I'll give you a live demo of City Viewer. I haven't got a glass. If someone can get me a glass, maybe I can borrow that one. Is Mark's or yeah? Okay. That case, that's better because I'm pretty sure he has I've installed it on this class yesterday for OpenApp. So screencast. In fact, I'll demo two applications that is using outer air library. Which is one is Moonglass. So the first one I'll show you is CityViewer, which I've shown you with the video. I run the CityViewer. Of course, you can run it with the voice command as well, saying OpenGlass CityViewer. Anyway, it will start loading some building models like this. So it's loading the 3D model, so you can turn around. The textures are still loading, so it might differ a bit. But if I turn around and aim at the building, it will show you the name of the building. And then if I tap while aiming at it, it will show some text information or picture of that building, and so forth, and go back. And I think if I head down there, there might be some photo bubbles, which is panorama picture. So if I tap, we'll load a panorama picture. Then if I can turn around and see how it looked like after the earthquake. Here, all the building blocks are.
Can you go to this building?
Sorry?
Can you go to?
This is just a panorama picture. You cannot go walk or so, but you can actually zoom in and see a closer look. Okay. So it's just a panorama picture taken at that point. But with the 3D models here, you can walk and the buildings will get closer to you. Of course, we don't have the internal models of the buildings, so you cannot, even if you walk in, you'll see nothing. But if you do have a 3D model of the internals of the buildings, then you can also show them. The other application developed using the outer air library again is a Moonglass, this one. And this is, we did it for one of the advertising company in US. And they wanted to create a kind of experience standing on a moon. And as you can see here, this is again a panoramic picture, and see the moon surface like this. And then if I look above, it will play a short video clip of the moon lander landing on the moon surface. This is just a video clip, by the way. So you can trigger different assets or media when you're looking at different directions and so forth. Once it's loaded, so once the video clip finishes, then it goes back to the panorama. This time loads up another set of panorama with the people on the moon. So you can see the astronauts, and I think you might see the moon lander backside and so forth. Again, you can zoom in and zoom out, see closer look. So anyway, these are the apps developed using outer air library. So that's the kind of apps that you can quickly develop using the library. And that library itself is, of course, free download. So it's basically using OpenGL ES commands to draw 3D objects. If you are familiar with OpenGL ES, then you can write your own renderer, but the library, Outer AR framework, or the library provides some scene graph structured rendering code, so you can, if you're not keen to write it yourself, then it also provides some model loader, so it's easier for you. And it's a component-based framework where you can pick different components and use mix and match them to customize into your own app. And also it's basically for Android platform. And we are also in the process of developing some web tools so they can upload your 3D models to see in the AR browser, but that's not quite ready yet for public access. But we are keeping it internally for development. And by the way, this is the website. So if you go to this website, you can download the library yourself. And by the way, I put a copy on the Google Drive shared folder, so feel free to grab it from there as well. So there are already quite a lot of Outer AR browsers in the market, which is Wikitude, Lyre, or Junayo. Any one of you have tried these apps before? No? So these are kind of, I think these days, Wikitude, Junayo is one of the main players developed by Meta.io. Especially, I think Lyre doesn't support much anymore for geolocated point of interest, but Junayo still, I think, still they support that. So anyway, the difference between these AR browsers and our library is that these other browsers mostly provides software development tools, either focusing on high-level content description, such as you can upload, you can create a web server, basically a database server where you can upload 3D models and description of the scene, and you will have to use their own browser they provide. So you cannot really customize the user interface, so you have to use their browser. On the other side, they also provide some software development tools that provides low-level functional modules. So you can create your own application, but these libraries usually misses the high-level abstraction of the scene, so that you'll have to code all the details of the scene by yourself. The Outer framework developed by ourselves is focusing on providing both high-level abstraction and low-level programming support in a seamless way. So those who are not keen to develop everything by yourself, then you can use the components ready to use and put them together into your own application quickly, but also provides some flexibility so that you can customize the user interface for your own purpose as well. So to show the capability of the framework, I will point you to a couple of apps we've developed using this library. So you've just seen the City Viewer. This is a phone version of City Viewer. And this is another application that shows the, this time showing the new development plan of the city. So this is showing the 3D model of the new stadium that they want to build. I think this is not the final design, but anyway, that's plan. And both City Viewer and City UAR is up on the Play Store. So if you want to try them, you can download it on your Android phone or tablet and then try yourself. And I think the GeoVoice is also up on the Play Store market. So you can, yeah, it's up on the Play Store market. So you can also try that yourself. This is more like a game application, and where you hunt for some mysterious flying creatures located in certain locations. And this is another application where you can visit Antarctica in a park. So as you walk inside a park, it will map the Antarctic terrain into that map, and it will show you as if you are walking in Antarctica. And if you visit certain places marked by this red flag, then it will show you some content, what happened there and so forth, so you can learn from there. So let me show you a video clip of those GeoVoice and Antarctic AR to give you some feeling of what kind of applications you can develop using this library. So GeoVoids first. So this is showing GeoVoids. So it starts with a map view. The software library, by the way, also provides you some abstraction of map view as well. So you can see this map view with your position pointed, and some sound coming on the background where you point at these icons, it gets louder. And as you get close enough to these points of interest, by the way, I'm walking towards these points of interest, and when you are close enough to them, by the way, this background sound is just New Zealand birds chirping. So this is not from the app, it's but from the real birds. So when you get close enough, it will kind of start beeping more faster, and then when you when you get to that point, it will start an AR view, and then you can see the flying creatures around you. So you can swipe to aim at the creatures and then capture them. You're not shooting them. The concept is not to shoot them, but to capture them. The newer version shows a bubble actually flying. This video clip's a little bit older version, but anyway, so you can do those things, and if you do some more Android development, you can also add some features such as, let me scroll, move forward. So this has also a feature where you can whistle to make them scared to fly together. So I think this part shows you whistling. So if you whistle, this meter on the right side will show you if you're whistling at the right pitch or too high or slow or short. So if you pitch at the right pitch, then it will scare the GeoVoids to fly together closely, so it makes you easier to catch them. So that's kind of a small application we've developed using the library just to show how flexible the framework is. So the outer air framework mainly we've are developing a client library that you can run on Android device so that you can quickly create a mobile AR application. So you can only use the client part of the library, but we also have a server library that you can also make the client talk to the server to download the up-to-date assets such as 3D models or description in HTML page or so. And we also have a small client, web client-based browser application, web-based application where you can, it's basically a web page where you can upload 3D models, and then it stores the 3D models on the server, and then it can talk to the mobile client app using REST API so that you can download 3D models afterwards. This is how the web-based authoring tool works, and we are hoping we can make it publicly available in the near future. But anyway, that's not, we are going to talk into details today, but we are mostly focusing on the client library for today. So this is kind of a structure of the outer air library where you can, it has low-level functional component where you can use them if you want to do the codings from scratch, but also the higher level components provide you much more easier way to quickly develop AR apps. And not only it provides AR view, but it also provides map view and list view, so you can browse the point of interest using those views as well. But today I'll be mostly talking about the AR view, which is the distinctive feature of the library. So, and you can use these ready-to-use components and just use them, or you can also extend those components to meet your own purposes. So basically, to extend those components is subclassing those Java components and overriding the methods it's providing, and so forth. So those you can easily customize are mainly two things, which you can customize the data structure of the scene. So you can define your own data structure for each scene so that you can customize the data you provide with the AR point of interest. And you can also easily customize your user interface using XML layout, which is default for Android development, and you can use those to create a customized UI layout. And of course, you can customize the behavior on what happens when you press the buttons and so forth using Android code. So now I'll kind of start show you how to use the outer area library briefly, and then I'll show you a little bit more polished version of the tutorial app. By the way, both this slide and the codes are up on the shared drive, so feel free to download it and try it yourself. So as an overview, I'll go through these kind of steps where first I'll point you how to set up the development environment, how to download the library and import it into your workspace. And then I'll show you how to create an Android app and use the library for your app, and show you how to add the 3D models into the scene and so forth. So I'm assuming that you are now pretty much familiar with the Eclipse environment. And for the library itself, it uses Google's own library, own mapping library, which is Google Play Service. So you might have to have downloaded it. I'm pretty sure you have downloaded it if you followed the guide we've provided earlier to set up the library. Anyway, to download the library, you can go to this website and download them. Maybe actually, let me show you the website. So it's hitlabnz.org. If you go to our website, in the products section, there is a mobile AR framework. Click there. You'll see kind of introductory material. You can download, there it has a link to the apps, so you can want to try those. You can also try them. Then if you scroll further down, there's a download link. You can download the library. And also we have some tutorials, more detailed tutorials of using the library itself. So you can see the tutorials and also the sample codes as well. So that's the library, but I've provided you inside the shared drive document already the library, so you don't have to go through this link, but you can just grab it from the shared Google Drive folder. So to set up the environment, first you have to download the library, of course, and then you'll have to basically import the sample projects. But before you import those sample projects, you might need some other Google libraries that our library references to. So the outer area library is based on Google API 4.1.2, which is API level 16, but I think it will build with API level 19, which you already have downloaded. But make sure it's not Android API, but Google API, because this Google API has a special additional support for older version of map library. And to use the newer version of Google Play map service, then you'll also have to include this Google Play service library, which comes with the Android SDK, and you can import them. And you'll also have to have an Android support library for, but I'll show you in a minute how to set up all those things. So let's start first with importing the library itself. So if you go to the Eclipse environment, and it's as simple as importing the projects that you have been doing quite a lot already. So first I'll import dependencies. So I'll choose file import, and then first we'll have to import some of the Google's own library. So I'll go to Android and existing Android code into workspace, and then click next and browse. And you'll have to go to the folder where you have installed the SDK, Android SDK. In my case, it's in dev, lib, then ADT bundle, then SDK. And inside the SDK folder, you'll find extras. In Google, there will be a folder for Google Play Service, and especially there will be a lib project folder inside there. And then you'll have to import this Google Play Service library. So if you click that and copy it into projects, it will kind of build by itself. So I now have this library project. And that's pretty much it, what you will need. And then if you click again, and now we will import our outdoor air library. So if you import, this time, since it's a Eclipse project, you can import it from general existing project into workspace. And then choose the project that I've put on the shared drive, and it should have two folders inside. One is the library and one is the sample code. So first we'll import the library first, then import into the project. And I think it will show an error because this library was compiled with an earlier version of SDK, and I think you only have the API level 19 with your setup. So to fix that, just go to right-click the library, go to Properties, and in the Android section, you'll see it missed the version. So just click this Google APIs level 19, which you might have downloaded for your setup. So make sure it's Google APIs module, not the Android module. Then if you have set that, you'll start to build. There is one more library that you'll have to add to this lib folder, which is support for older versions of Android devices. So to do that, you'll again have to go to the folder where the Android SDK is installed. In my case, it's here. Then if you go to Extra, Android Support, and then V4, there should be a jar file. And you can drag and drop into this libs folder and copy it. And that should fix all the problems of the library. So by the way, this step is all explained on our website. So if you click this Getting Started tutorial, it's this PDF file. This explains in details how you set up the library, download and set up the library. So don't worry too much about what I did if it doesn't make sense for you, which requires some previous knowledge about setting up the Android project. But anyway, that's the library you can set up. And I'll just import one more project, which is the sample code. It comes with the library. So I'll just show you how it looks like. So sample component, just the sample code comes with the library if you download it from our website. And again, this one might have an error because it's using the older version of library, Android library, Android SDK. But again, you can just choose this Google APIs you have in your setup, and will make the errors go away. And by the way, this sample code has all of the components such as AR and map and the list. So you can, if you are interested to look furthermore into the library, try to look at this library. But for today, I'll be creating a new project. Actually, let me run this. No, I think we don't have enough time. So I'll just show you how to create a new project using this outdoor air library. So it's nothing different than just creating a new Android app project, but only difference is that you'll have to add the outdoor air library to the build path so that your project knows to compile with the outdoor air library. And then a couple of things you'll have to do is to add permission to the manifest, because our library is using location information and access to camera and so forth, and Android kind of has a certain its own rules that you'll have to declare what kind of device says you're accessing, so that the end user can be warned, get the warning that your app is accessing those private information. And then It's basically creating an activity and coding the activity. The only difference from standard Android activity is that we provide a kind of a base activity that you can extend from, which will take care of all the AR bits for your own purpose. So let me just do that right now. So the way you do will be just creating a new Android application. Again, same way. I'll call it sample AR. Then web inject. And you can go with, you can just go with KitKat, which you might have in your settings. I'll put the minimum requirement to 15, which is kind of, then I'll click next, and the rest will be the same. I'll just go with the default icon and blank activity, which we did so far, and I'll leave it as a main activity and finish it. And so that's just a blank kind of project we've created. Now we'll have to add the library. So to add the library, you right-click on a newly created project and go to the properties where you set the Android SDK. If you scroll down a little bit, there will be a Java build path section. And here you can add other libraries. So if you click the library section, actually, this is not the place you add the library. It's just in the Android section where you can actually add the Android library. If you, the other one, Java build path is when you add the standard Java jar files. But for now, we'll just adding an Android library, so it's just in the Android section. Then if you click add, you'll already see these two libraries you can choose from. And you can just choose the Auto library and click OK, and then that's added. So now you can use Android Auto library functions in your project. And that's it. And again, in the manifest, you will have to add some declaration that you're using GPS and so forth. So the permissions that you will need here, you can easily grab it from the sample code provided by the library. And if you go to the sample away component and click this manifest, you'll see that this asks for many different permissions. And for today, we will just need these three of them. These are the permissions that you will need if you are going to use the map API, but since we are not going to use the map API, we'll just need these permissions. And I think you can ignore the OpenGL ES version, but let's copy it. So that's all what you will need to create an AutoAR application. So that's the setup. So we created a new project, added permission to the manifest, and now we are going to create another activity that does the AR view, and wire a button from the main activity to start the AR view. So to create a new activity, we'll do it a little bit different from what we've done so far, because we'll be using a different class. But actually, maybe it's easier if you just do as what we did before. So maybe we'll just do it as like, go to File menu, New, and then you go to Others, and inside Android, you can create a new Android activity. Then we'll just go with the blank one. And then we'll call it AR activity. And then the hierarchical parent doesn't have to be paired. And now we have another activity that is for AR, but this doesn't does anything with AR yet. No problem. Which connector you need?
What's the other end of this?
Should be in the drawer, or the second one. I think I saw it yesterday. Okay. Okay, so let's see. Where were we? So we just created a blank activity. And if you go to here, you will see this AR activity created by itself. But what we will do is actually delete all these methods because we don't really need them anymore. And actually, since it's an AR activity, it's not to use the plain activity, but if you just type in OA AR component base, then I think I'll have to import it. So this is the base class that the outdoor AR library provides. So you can just call that. And once you've done that, this is all code that you need to start AR. So, and the only thing we are missing that we are starting with the main activity. So we'll just add a button to launch that AR activity. And by now you might be quite familiar to adding a button to a layout and then like just dragging a button from here. And then setting an on-click property for it. On-clicked button. And then you declare this method inside the main activity. Yeah, these are all you've already went through when we were learning other stuff. So I think it might be quite familiar for you. And then here we'll just start the activity. Start activity intent, new intent with this, and class, we will be launching the AR activity. So that's code. So when so when you click that button, it will just start the activity. And now we can try to see how it looks like on the phone first, and then we'll do it on the glass later. So I'll right click and run as. Hopefully I didn't miss anything. Missing something. So that I would need this, which seems I might need to again. So I've just built it. We did nothing but just change the base class to outdoor AR components, one of the outdoor AR components, which is OAR base. So when it starts, it's just the main activity here. If I hit the button, it will start the AR activity. And as you can see here, we didn't wrote any code, but it just starts getting the camera feedback. And you will see by default this kind of grid. It's quite slow on here because I'm kind of capturing this screen and showing them to here, but it might be quite smooth enough on your device. So that's basically how you can add AR component to your app. Let me go back to there and go back to my slide. So that's how you add an AR activity. And now we might want to load some 3D models into the scene. So we only have the grid, so it's a little bit boring. So to prepare 3D model, it loads OBJ MTL model. If you're familiar with it, it's very basic text-based file format, which many of the 3D modeling tool can export. So you can use Maya or 3ds Max or even free software such as Blender could also generate OBJ. Or if you are an architect, then you can also use SketchUp to create an model. And then we are at the lab, we are using quite a lot of SketchUp models because most of the times the models we create has to be registered in the real space. And SketchUp has a special feature that you can actually assign a latitude and longitude of 3D model and use the Google map or satellite image to register the building at the place. So we use that quite a lot to accurately register the 3D model. It might be good for you to try that one as well. And or otherwise, you can use use Google Map service. Or for myself, I use this website where you can click on a Google map and it gives you a latitude and longitude back. So it's quite handy. So once you have a 3D model and the latitude and longitude that you want to show the model, then that's it. That you. And where you add the 3D model is inside this folder in your app project. So in Android projects, there is a folder called assets where you put the additional resource files that you want to load. And inside that folder, this outer AR folder is the folder name that the library initially looks for. Of course, later on, if you learn more, then you can change this name of the path, but this is the default path. It looks for the 3D models. So if you have a 3D model, there you have to follow the naming convention that the OBJ model has to have this model.obj name. But instead, you can create a folder that of your own name for that model, and then put your model in there. And for each model, you'll have to create a folder and then put that OBJ file inside there. And if you have more than one OBJ file, then you'll have to create more than one folder and the OBJ file inside there. And then loading those OBJ models in your code is to override this onSetUpScenes function, where you can load the model and then add to the screen. And handling the scene selection events, such as when you tap on a 3D model, it will call your application back, and that callback is this method. So you can know which 3D model is selected. And you can also do some more code if you want to mock your locations, such as if you're testing your app indoors and you want to fool the device as if you are standing in another place outdoors, then you can use this mock location method to assign a latitude and longitude where you want to simulate you're standing at. So so you can load the scenes by code, but it's quite cumbersome if you every time have to update the code. So the library also supports a couple of methods, such as a SQLite database or XML file that you can copy and define the scenes inside there. So those are there. But for today, we'll just code because that's the simplest way to do it. So let me show you how to actually add the 3D models into it. So maybe I'll just copy some of the 3D models from the sample project. So if you open the sample projects, there will be already a 3D model inside there. So I'll just copy some of them. Copy both of them. And this is the project we've created. So inside the assets folder, we just create a new folder inside. Then we call it outdoor AR, which is the default folder it looks for. Then we have to have another folder which is called 3D models. Then inside there, I'll just copy those two folders. So this is folders that has OBJ models inside. One is basketball and one is just a box. So that's the 3D models are there. And inside the code, the AR activity, which is blank, we have to override the method, which is source override methods, and then the base class there should be a method that is called setup scenes, and then so here is where we set up, And maybe we'll just override one more, which is called when the scene is selected, just to show you how it is. So that's there. So we don't need to call this super method, so don't be bothered with that. Actually, I think we'll have to call it. We'll just leave it there. Okay. So, and then what all you have to do is it will be passed with the data manager, which is basically managing the scenes you load.
Alright, do you need me with glasses?
Not for now, but maybe later. But okay. I think I can live without it.
Do a demo for 5 minutes.
Okay. And with the data manager, there will be a method. There will be a method called add scene. So what we all have to do is create this scene object and add to the data manager. And to do that, maybe I'll create a variable here, wait, scene, and then that's new. Actually, yeah, that's a good way. Wait, scene. So you can create a new scene. You can create an empty scene, but if you hover over this plus, there's no. I think by default you can have the latitude and longitude. How should I? Go to. There's a constructor method that you can actually define the latitude and longitude from the beginning. There we go. So you can put latitude, longitude, and then. So this is a constructor that receives latitude, longitude, and then this is a short description. And this part is describing the folder name of the 3D model it should load. So this string is actually matches this 3D model folder. And this is a latitude, longitude. I'm not sure where it is, so let's try to put in something else from the iTouch map. That long. This is just a website I've shown you before. I go to University of February. There we go. It's there. So our building is. Where's our building? Yep, there we go. That's HitLab. That's HitLab. So maybe we'll put something over there. So we'll just click there. Then if you click at the marker, it will show you the latitude of longitude of that point. So we'll just copy that over. And then put it there. So this 3D model will appear somewhere over there. And that's all we'll have to do. So if I run it now. Oh, that's not the one I wanted to run. How do I cancel it? To cancel it, there we go. So I didn't want you to build that one. I wanted to build this one, which was re-recording. Okay, so it will load up. And if I did everything right, then the model should appear somewhere over there. Okay, the app started, I click the button. Then I think it's a little bit far away. As you can see, this is just a cube model loaded, which is something over there. So as you can see here, it's quite simple to just add a 3D model. So And then what we'll do now is we want to add some interaction where you tap on that model, we'll do something, and we'll just do, as you can see here, this is a method called onSceneSelected, and it will call back and give you the scene. So we'll just do nothing with the super thing. So we'll just make a toast method, just as an example. Next. And then maybe we'll make a toast with the scene's name. Get name. And this is the name, red Android box. So and then duration, short, show. And whenever we touch that one, it will now show you the name. Okay, I launch the AR view again. Then if I tap at that one, it will create, shows the toast. It's a little bit hard to see from here, but it's saying hello. I think it should be red box. Yeah, red Android box. So it's basically toasting the name of that scene you selected. So that's how easy you can load a 3D model and then place it somewhere, and then do something when you are selected scene. So now I'll go a little bit more further. So far we've been using this OA scene class, which is just a basic scene class that you that's provided by the library. But you can actually extend this, so you can extend this class and create your own scene and add more data structures, such as if you are creating a building scenes, an application about buildings, then you can add more data structure to describe about the building. Or if you want to build an AR app about the plants around, then you can add more data structure describing about the plants, such as the species or some sort of those data structure. So it's as simple as just extending the Java class and adding more data for you. And customizing the UI, you can override the setup UI layout function from the base class. And in there, you can pretty much load the XML file for standard Android UI. Then you can add that as you're calling this add content view function. And then it will create an overlay on top of your AR view. So then the rest of the code is just same as the Android code that you can do, add a listener for when it's clicked or something, and then you can write your own customized UI code. And before we go further, no, actually, let me just keep going on and then show you the demo afterwards. So I've just shown you the AR component inside the library, but you can also, as easily as the AR library, you can easily add the map and list component, which shows a list of the scene or shows the same scene on the map as an icon as well. So instead of extending the OA AR component base class, you can extend, your activity can extend OA map component base or OA list component base. Then you can, pretty much using the same structure of the code, you'll be able to show the same scenes on the map and the list as well. And for the map, you will need to use Google Maps Android library. And for doing this, you'll have to have an API key because Google requires you to register on their server. To do that, you'll have to go to this website and create a key, and then copy that key into the code, and you should be able to use the map. But we won't cover this for today. We'll just focus on the AR. So now what we'll do is make this run on Google Glass. So we'll, instead of starting up with the main activity, and then you'll have to tap that button to go to the AR, it will be more relevant to just start from AR. So I'll show you how to do that. And although we kind of tap with finger to show the name of that scene you selected, you cannot really tap because on the tablet or phone, you can tap on different places, but when you're looking on Google Glass, you can actually tap at the certain places unless you show the cursor. So what we'll do is, instead of tapping every time, we will just make it to show a reticle, so that when you aim at it, it will show you the name of it. So to do that, we'll add a custom UI layout and also add a timer, so that every time, every 1 second, it kind of simulates as if you're touching the middle place of the screen. So let's start with adding a, first of all, let's start with manipulating manifest. So currently this is the main activity, but we will change it to this AR activity as a launcher, so it will start with the AR activity. And of course, you can add the voice trigger here, as you've learned yesterday. But we'll just skip it for tomorrow, for today. Inside the AR activity, just one more thing. If you run it, it will show you a title bar. So we will kind of try to change the app theme to make it full screen. So the AR activity, Android theme, and this is just to make it a full screen. So let me actually copy from here, which is easier for me than typing. It's the full screen. So this is just to make the activity full screen. And coming back to the AR activity, now we'll have to override a couple of more methods. While this was, yep, that's fine. This was called when it was scene was selected. We'll have to again trigger every second to trigger a touching event at the middle of the screen. So to do that, we will create a timer. And when we start this activity, we will have to start this timer and schedule some task. And when we stop this activity, we will stop the activity. And to do that, if you remember from the very first tutorial, we will have to override the on-pause and on-resume methods of the activity class. So we'll override that method. And if you scroll down into the activity, I think it's actually here, on-pause and on-resume. This is called when the activity starts and stops, and to be more precise, when it's shown on the screen and it goes away from the screen. So first, when it shows on the screen, I'll just change the order, because that's how it's called. So you have to start the activity. So we will have to start timer, schedule a timer's task with this method. So this is, we'll create a new timer task. And then it will be called, after a delay, we will just call it maybe 1 second after it's created. And every 1 second afterwards, it will keep calling it. And then in the timer's task, you'll have to implement methods. So if you hover over it, it will say add an implemented method. And this is basically the code that it will be called every 1 second. And here we'll just call another method called timer task. And then we will define that method here, void timer task, so once the activity resumes, it will schedule a timer task that calls this method every 1 second. Inside the timer task, we will just simulate as if we are touching something. And before touch the center screen. And then in on pause, we'll have to make sure we stop the timer, otherwise it will keep calling on the background. So to do that is just to go with timer, cancel, and there is also another method, maybe purge, is just canceling the current task. And so that's all, that will stop the timer when it's paused. So you'll have to create a touch event at the center. So what you can do now is I cheat a little bit. So we'll have to know what the center point is because it has different screen sizes. And of course, we know the Google Glass, but it's safer to do that way. And to do that, you'll have to go get the window manager and then default display and get metrics. Or since it's Google Glass, let's just go with triggering touch at the middle of the screen where we already know. So to just trigger the screen, so we get the scene view. Then trigger touch. And then we know the size of the screen, which is 640 by 360. But we want to touch it in the middle, so we will just half it. So that will do the trick. And then let's try to run it and see if I did everything correctly. So I'm not running on the Google Glass yet, but let's assume this is Google Glass. So it will, this time it will start from AR. Oh, actually this will not work because we've put this 640 by 360, which is different from this screen size. But let's assume kind of lower up corner is 640 by something. So maybe I'll have to aim it somewhere here. So if I aim it here, you'll see that toast coming up even if I didn't touch. And if this is running on the Google Glass, it should be the middle of the screen. So to make it more compelling, maybe we'll add a reticle. I'll just show you how to add a reticle on the screen. So to do that, we'll have to override another method. So to do that, right-click, source, override methods, and then this time is set up UI layout. This is where you set up the UI layout. And the superclass kind of set up the AR components, so we keep that there. And then here we have to load the XML layout and add it to the scene. So if you go to the resource folder, when we created this activity, this kind of XML we generated as well, so we will reuse this and just remove this hello world. But maybe we'll add a kind of reticle kind of image. I'll just copy it from, I don't think it's in that sample class, but if you have downloaded the final project I uploaded on the share folder, this one is the final code, by the way. I think I have an image of a reticle there. Uh-oh. I didn't want it to do that, but just smaller. Tutorial projects, software, tutorial, then the resource folder, drawable. Yep, there is a reticle. You can use. So I'll just create a drawable folder, which is neutral to screen size. Then copy that PNG file in there. Then there. And then to add the image view here, you go to image and media. There's an image view. Drag and drop at the center of the screen. Then it will ask you for the image. So inside the project resource, I see it's called, what's the name? Reticle, I think. Yep, reticle blue. And then you'll have that reticle there. And you'll have to load this XML into the AR view now. So to do that, there is a Android class called, I think I've explained it here, layout inflator. So that's the class in Android that you can load the XML file, especially. Then from context is this application. You can use base context. Then inflate this resource file, RID Oh, I need to layout. I think it was activity air. And for the root, you can just give it null. Then once you've done that, you'll have to call these classes add content view with the view we've loaded. By the way, this inflating will create a view, so we'll put it in the view. And then just add that view to the content. And this parameter, you'll have to add layout parameter. This is a little bit new layout parameters is parameters. Then you'll have to have that argument with 2 ints, which is basically layout parameters match parent. So this is just saying that we add this view to match the parent size. This is training size. So once we've done that, that will add that XML, load that XML layout, and add that to the screen. If you run it again, and now you'll see, in addition, in the middle of the screen, you see that reticle loaded. Although it's not, I think I have to aim it like this. But anyway, if you were running on the Google Glass, it should have ran on the middle. So that's that. The code I've put on the shared folder has a little bit more code that makes the app look more nicer, but maybe you can read a code by yourself. And stop for there. We left it here. So that's how we add a timer and then trigger the touch event to make it as if you are touching the middle of the screen every 1 second or so. Other tips, I think you've already learned how to detect this touch event using on-generic motion event. So you can do those and use different tapping or swiping gestures and so forth. Other thing I could point to is if you call this get sensor manager method inside that activity, then you can also add a listener to the sensor, which is listening to your head orientation, so that you can do some head gesture-based interaction if you want to do. So couple of tips that when you run this application on Glass, Glass doesn't have GPS, so you have to pair it with a phone to get the GPS location. So beware of that. And a couple of other options you can do is simply pair them, or if you are keen with Bluetooth programming, then you can also actually get the GPS location from your phone and stream it through Bluetooth. And of course, you can use a fake location if you are just testing it. And you can also turn off the camera background. Sometimes it's more compelling without the background with Google Glass, which is transparent screen and also have a background. So you can also turn off the screen camera background if you want by calling this enable camera background method or overriding setup options to set the options for default value. So that's that. I think I've shown you the city viewer for Glass demo at the beginning. So if you want to try it on your own Glass, then you can do that. Otherwise, I'll just wrap up with pointing you to these two websites which I've shown you already. That's it for my lecture today. So thank you again for coming, and thank you for your patience with my having some error with while I was coding. If you have any questions, feel free to ask me over the afternoon. I think the rest of the plan is to give you some time to try the codes yourself, and I think at 4 o'clock we'll kind of gather together and get some feedback from you. And I think Mark asked you to give a small presentation or a small picture of your own designed application, right? So for that, I've created a share folder on the drive where you can upload your slide or a picture or whatever you want to present. So in the same Google Drive folder, where is it? The class inside the class material, there is a folder called project submission. So inside here, you can drag and drop your, could be a PowerPoint slide, or it could be just one image that you designed or whatever. Just drag and drop here, and then we'll use that folder and show and explain to others and share. And also, I think Mark will give you some feedback about the design and also give you some directions how to develop it further and so forth. So that's it. Thank you, and maybe we'll have a lunch break now and come back when you're finished and work on your project a little bit more. And if you have some questions, you can ask me. Oh, okay, I'll help you now. Let me just first stop the recording.